Everybody, thanks for being so timely coming for breakfast. Did we have a good day yesterday? Did we learn something? That we're going to go home and test our water, right? That's one thing. Everybody I see, did you know that chlorine actually eats away at PEX if it's wrong acidity and temperature? And hey, I tell everybody that now. I'm like, now I want to go test my water at every single project I ever worked on. Well, today we're going to change it up. Yesterday we talked about structure. How do we put the bones in the house, right? Kind of behind the walls and all that kind of good stuff. Now we're going to switch gears a little bit, and we're going to talk about, now that we built this incredible structure, the problem is it's tight. So we've got to deal with the science of ventilation and comfort, and it's really an interesting area. So we're going to talk about that, but before we begin, like all of these sessions are sponsored. So this session is sponsored by Epcon Homes, Epcon Franchising. But we're going to run a little video that they've given us to talk about Epcon and their franchise.
Are you ready to catch the wave in 55 plus home building? At Epcon Franchising, we work to support home builders like you to build homes, neighborhoods, and lifestyle that is extremely popular with the 55 plus demographic. The 55 plus market is overflowing with potential, and by working with over 75 entrepreneurs across more than 25 states, we are helping our franchise builders ride this wave in the residential real estate market. At Epcon, we offer copyrighted designs and a streamlined approach for home builders to manage the land development and home building process for 55 plus communities. As an Epcon franchise builder, you'll receive access to our business blueprint that has made us a top U.S. home builder year after year. You'll work with our experts in land, marketing, sales, and purchasing using our time-tested processes. Many of our largest franchise builders joined us during the global financial crisis. And although they faced obvious challenges along the way, they've stuck with us over the years, and they've consistently grown their businesses along the way. They were able to catch the wave at the right time.
Everybody here is knowledgeable. Epcon has had such a rich history and have a large network of franchisees that add so much value to the brand. Always looking to innovate, always looking to make things better. So that was one of the main reasons we jumped in.
I'd always thought about doing communities, just felt like didn't have the experience or the know-how to get into something that large, and Epcon paved that way.
Upon investigating everything Epcon had to offer, decided it was a perfect complement to the business that we're doing already, and a great way to scale up our company as a whole.
There's a system, there's a process, it's tried and true. That's really why we bought into it. Is, of course, we could have come up with something on our own. It would have taken a long time with a lot of mistakes, and we wanted to shorten our learning curve and jump right into where we wanted to be.
Where else can a small boutique builder join a top 60 builder and have access to all the resources that this company has available?
We can't control the economy, we can't control the housing market, but we can make sure that we have the best products and the best processes to succeed in the marketplace.
At Epcon, we give existing home builders the tools to become dominant players in their local markets.
Ready to dive in? Catch us at Break Service, and let's catch the wave in 55 and up home building.
Anyway, all right, so let's talk about how we build tight, ventilate in every home, in every market, in every band. A long time ago, we didn't have to worry about this. And it wasn't actually that long ago. If you actually go back to the 1970s, we were building houses so leaky that I'd say we had an air management strategy, and it was to allow the house to manage the air. If you've ever read any history books about the people that lived in the American plains, they'd talk about waking up in the morning and dusting the snow off of their comforters because the snow would blow through the windows, and wiping their windowsills down every day from the dust that would blow in the house. We built some pretty leaky structures, and that way our inside air and our outside air kind of equalized, over time. The challenge is you got to the 1970s, and we started inventing tools, and we started looking into building science, and we had the energy crisis more specifically. I lived through that. A couple of people have enough gray hair here that they actually lived through that. And we started tightening up our homes. And I remember originally, man, we'd take plastic, right? Plastic sheeting, and you'd put it over all of the insulation and then put the drywall up against it, right? Don't do that now. But we used to do all of that kind of stuff, right? We'd tighten these homes up because we were trying to get a really energy efficient envelope. But then we started realizing when you tighten a home up like that, there are unintended consequences with respect to condensation and air movement and the amount of air in the home, the quality of the air in the home, the volatile organics that are in the home, the particulate, et cetera. So we got to a point where we figured out, well, wow, with the technology that we're building, you can build too tight. You can make a house really tight. But without the air management science side of this, it's not a healthy home. It's not a comfortable home to live in, and it ends up with a lot of consumer complaints. So from there, we have a kind of a new era. Now we're actually looking at what I call a new term, atmospheric management. And the reason I call it atmospheric management is because when you start talking about indoor air quality, people go, oh yeah, well that's particulate. We're going to filter that. Yeah, but it's humidity. It's also gas concentrations. What about CO2? CO2 is a big deal in a home, and how are we managing that, right? What about radon? What about, you can start walking through all of these different, what we really are trying to do is we're trying to create an atmosphere inside a living structure that is healthy and comfortable for people to live in. That means we're going to manage particulate. That means we're going to manage gases, right? We're going to manage temperature. We're going to manage all of these things in a fairly complicated system. So it used to be we had temperature control, and that was what we did. It wasn't really atmospheric control. It was temperature control, and now we have atmospheric control, right? We're trying to control temperature, humidity, air quality, particulate gases, energy recovery, room-to-room and inter-room air stability, even air safety with things like CO2, for example. We have these other systems that measure smoke, and CO2 and things like that. But if you're actually measuring and managing the entire atmosphere, my view is those systems are all going to coalesce at some period of time. We're going to be sampling the air in our homes, and it's going to deal with all of these issues, and it's going to deal with these issues in a closed-loop system. So every day, every hour, we're going to have homes that are comfortable to live in, they're going to be healthy to live in, and it's going to give us information back to us, telling us that we're living in a much better home. When we get there, the difference between a used home, where you don't know whether that home is hurting the health of your children, and a new home where you have a monitor on the wall that shows them that every single day they're living in a healthy environment, that will be a huge differentiator for our industry and ability for us to extract that. We have a lot of new parts in systems that you hear about all the time, ERVs, and we've got all kinds of electrostatic filters, we got 4-inch filters, we got HEPA filtration, we got MERV ratings, right? We've got all kinds of control systems that are out there as well. So this stuff is all starting to come together. And today I'm super excited because we've got 3 individuals up here from completely different backgrounds. We got Cam from Carrier. He knows all about the technology of all the parts and pieces that go into the home. They got incredible research centers. We had several pre-meetings with Carrier to talk about their technology. He's going to come up here and talk about why buildings fail and what you can do about it and all that. And then you got a superhero of mine, Brian McCarthy. Brian owns and runs and founded Abrazo Homes, which is the largest private builder in New Mexico. He absolutely terrifies the rest of the builders there. He is a visionary. No, I'm serious. You're a visionary. He does things that other builders don't do. It terrifies them and makes them change as well, on your coattails, but they change because they have to. Because who wants to buy a home that's not an Abrazo home? Nobody. That's the bottom line. If you're in Albuquerque, nobody wants to, you're forced because you're out of homes. That's why I buy a different home, because you're out of homes. Close to it. Yeah, but I'm serious. He has positioned himself building a better and different home. And you're going to talk about your history. You didn't always build them that way. My guess is your first home was pretty shitty. Okay, I've never had him go, yeah, I built a shitty home. Okay, this is a first. Oh, but we learn. Right? We learn and evolve. And he, as a builder, is going to kind of tell you his journey. And Jefre Outlaw, I've known for a very long time. Jefre was your worst nemesis. He was actually a mold inspector for many years, right? So he was out there seeing the carnage in our industry, how homes fail, figuring out and going through the diagnostics to figure out how they failed, what they needed to do, how do you remediate. And then he switched from there and he went into the teeny home industry. And let me tell you, the worst case scenario for indoor air quality is a teeny home because you have no volume of air. Think about it. Any outgassing, any particulate, right? You're talking about 300 square feet or 400 square feet. The volume of air you live in, even 2 people sleeping, the CO2 that they put off will change the gases and change human health and behavior in the home if you don't manage that air. So it's a really, really, really significant issue the smaller and tighter you make those envelopes. So he's going to talk to us about some of that stuff as he comes up here. So that's who we've got, and it's going to be a great meeting. And Cam, I'm going to turn it over to you. You're going to come up here, and he's going to talk to you about the science and the failure of homes in the market today.
Perfect. All right, everybody, good to meet y'all. Thanks for having me here, Tim. Excited to talk to you guys about kind of what we see from the indoor air quality perspective and managing indoor air quality from Carrier. So I'm going to give you, where do I go from here? I want to start with a little bit of my background as to why I believe I'm qualified to be here. And some of the content that Tim and I talked about in those initial sessions. So I started my career in specifying engineering on the commercial side. So spent several years in Atlanta building commercial buildings where ventilation and air control is actually a huge aspect of building commercial buildings, right? If you go in and talk to a specifying engineer on the mechanical side, the biggest pain in the butt for them is ventilation. It drives copious amounts of load, but it also brings in lots and lots of fresh air for those occupants because they have, at a certain point, corporate America has figured out that they need to make sure they have healthy homes, and the building code supports that. I then moved into a residential space where I was floored that there's not really a ventilation code as it comes to residential construction. We don't really have one. And so while I think at some point that's going to start to change, and all of you being here and thinking about this ahead of time, right, the carrot method versus the stick method, eventually code's going to start to hit us with a stick in terms of ventilation because they'll start to figure out and see cases like we're going to look at down in Houston. But I moved into that residential space, and I actually ran an indoor air quality control product for Honeywell Resideo for several years. So I spent a lot of time trying to convince contractors who are terrified of everything that they need to go in and talk about indoor air quality. And we're going to talk a little bit about why they didn't want to do that and why there's such a struggle around talking about this with your buyers, with anybody who's renting homes, that it's a really slippery slope and a really touchy subject. So I've spent a lot of time looking at that and then, of course, understanding the technology. And now I work for Carrier. I'm the national account manager for our ductless portfolio in addition to some of our ventilation products and some of our other spaces. So I deal a lot with high-performance builders putting in crazy product that they probably shouldn't be putting in and spending too much money for. So I am supremely qualified to convince you to buy more expensive stuff. That's how I like to think about myself. I sell really expensive things to people who don't want to pay for it. I do it decently well.
I know it's going to interrupt your presentation, but I couldn't help when you were talking about regulations.
Yeah.
There's nothing guiding builders today in most markets
to
have to do anything. I think we can look at that. We've got to look at that two ways. If we only follow regulations, then we're building a commodity. Right. And we really have to raise our hand and go, yeah, I just build a commodity. I build the lowest spec possible home that just barely meets regulation, which every home has to.
Yep.
And your ability to differentiate against the used market diminishes. I almost think we should embrace this and go, good, there's no regulation, which means all those lousy builders are going to build commodities.
Right.
And there's going to be other builders that aren't. And we're going to build a better product, and we're going to be able to educate our clients, and it's going to be the difference between a home you live in and a home you die in. Yep. And, I bring that up because Volvo's entire ad campaign in the 70s and 80s was, why would you buy a car that's going to kill you? And it was really successful. Why? Because they exceeded the crash specifications on all of their cars. They didn't wait for the government to enact them. And I think we have the same opportunity here. So I know it's messed up your presentation, but I think what you said is really profound about, are we waiting or are we going to take advantage of this and go into a blue ocean and sell products that nobody else offers?
Yeah, we at Carrier refer to builders kind of in two different buckets, right? Are you building a code or are you building above code, right? I sell to the guys who build above code. If you're building to code, you build to code. And there's nothing wrong with that, right? There's a market for people that build to code. There's a market of buyers that want to buy that house because they don't care about some of this stuff. And that's part of the challenge here is we got to figure out how to get people to care and think about it so that when they come into your home and you're building above code and you say, these are the things I'm building above code in this house, they're like, okay, I get that. I see the value in this home, because that's the biggest gap, is the understanding and the value gap from the buyers, from renters, and then eventually, right, if you get to enough scale on the used home market where they go in and they're educated enough to go into a used home and say, does this have this, and this? Oh, it doesn't, because the cost to add it retrofit is substantially more than the cost for you guys to build it right off the bat, right? When there's no walls and there's no roof, and it's way cheaper to put some of this stuff in than if you try and go retrofit it into a house. So I think that's where a lot of the opportunity comes from. So digging in really deep, as Tim said, I'm going to talk you through a little bit of kind of cause and effect, but we're going to go backwards, right? Effect and down into cause, and then how we take care of that from an equipment perspective. There's a lot to cover here. This is a huge space, so I'm going to try and condense it, and then I'm happy to follow with anybody and talk through any of these specific items. I could probably spend a day and a half specifically just talking through all of the aspects of this, so I tried to bundle it all together for you. What's really challenging about indoor air quality as it comes to people grasping it and understanding it is you're into health issues, right? Temperature, you can feel. Like they can walk into a house and they know if it's hot or if it's cold. If they walk into your model home and it's really, really hot, they got a problem. My guess is your model homes don't have, right, really high temperatures on their set points in the summer, and probably not really low temperatures in the winter. So they understand that. They know how to walk in, and your model home agents or your salespeople can talk about that. They kind of get humidity, right? They can kind of feel it, but not really. It's hard to perceive humidity, right? But people have a better grasp of that, especially in climates where they know it matters, right? I live in Houston, the humidity capital of the world. We understand humidity. Ironically, one of the worst dehumidifier markets in the world, but we can talk about that later. I also previously lived in Minnesota. So the cold and lack of humidity capital of the world, where everyone goes into a house and they know I should probably have a humidifier in my house, or it's going to smoke my electronics and my nose is going to bleed.
There's a pipeline opportunity. You could pipe Houston air to Minnesota.
Yeah, they keep shutting down those pipelines going north to south, so I don't know. Maybe we could try. But as you get into more of these other aspects, you're getting into specific health-related problems. So if you look at a house in Houston that's sealed up too tight, right? They run their bathroom fans. If there's no ventilation, they're going to start to see mold. They're going to start to see that accumulate because you're not managing the humidity. That's a hard thing to talk about to a homeowner. Hey, if you don't put this in, your house is going to mold, right? How do you say that to somebody who's buying a house from you? Same thing on allergies, right? You know, they move into this house and all of a sudden they start breathing the air. They start to get used to it. It's too tight. The air can't get out. You don't have any exfiltration in the home because we've built it super tight. Their allergies start to crop up. Their noses are running. They're sneezing. They're doing all this stuff because they have a dog. They're allergic to dogs, but in their last house, it was breezy as all get out. And so you had this nice air balance here. It just concentrates. And that dander is everywhere. And they start to sneeze all the time. Or if they're in the north, and this one actually happened to me, it's sealed up too tight. That CO2 gas starts to concentrate. One of the leading indicators of really, really high CO2 is you sleep like crap because you're not getting enough oxygen to put yourself into REM sleep to allow your body to actually relax. And so if you have that concentration of CO2, you start to have problems with sleeping. That's happened to me. I lived in a house in Minnesota, 0 ventilation. In the winter, when I had all my windows shut because it was negative 20 degrees outside, I had accumulations of CO2 and my family couldn't sleep. And so we had to figure out how to manage that in our home. And once we did manage it, we were able to sleep again, which was really nice. You don't realize how much not being able to sleep well impacts your life until you don't sleep well.
And only on tonight, 3.
Oh, okay. It's going to play as soon as I hit go. All right. So I have a very specific use case for this. This is a video from 3 weeks ago in my town in Houston. Ironically, as I was putting this together, this popped up on the news one night. I was like, what are the odds that this is going to pop up and be relevant? But I wanted to play this for you. This is not like theoretical stuff that's happening in the world, right? Mm-hmm. We're not trying to. These are things that are happening right now. So I want to play this for you. This is a production builder in Houston. I am very much going to hope that we're going to skip their name because my purpose here is not to call out the builder. It's to call out the situation.
I have protected the innocent.
All right, good.
And only on Fox here tonight, 3 League City homeowners living on the same block have filed a lawsuit against their home builder for allegedly causing dangerously high levels of mold. Fox 26's Randy Wallace is joining me now live from League City with the exclusive.
Yeah, right, Anthony. Now, according to the lawsuit, a mold assessment consultant told the 3 homeowners, in her professional opinion, their homes are unfit for human habitation.
The second story is definitely where you can see the most prevalent mold.
This is Ashley Olive's dream house, but she and her family haven't lived here for almost 2 years.
I tore out this supply vent, and this is what we found.
According to lawsuits, the reason Ashley and 2 other homeowners in the same block have fled their homes, dangerously high levels of 3 kinds of mold.
It's not healthy for them, for anyone to live in an environment with extraordinarily high mold counts.
Ashley's attorney, Ernest Freeman, says a professional mold inspection confirmed the dangerously high levels.
In the tens of thousands of mold spores per cubic meter, in some instances over 1 million. Specifically deal with improperly ventilated attics, and then the attic space not being properly sealed to the living spaces below. And so you have a hot buildup of humid air.
It was consistently reoccurring enough.
Ashley says she and her family moved out of the house in the summer of 2022 after a licensed mold consultant issued a letter stating, in her professional opinion, the home was unfit for human habitation.
It really just depends on the day. Some days I'm mad, some days I'm sad. More than anything, I just want to bring my children home.
Ashley and her husband are paying the mortgage, rent on another house, and all the bills for both houses.
There was certainly some mom guilt knowing that I had all 5 of our children living in this home, knowing that it could be potentially affecting them in their future and what that would look like. We definitely struggled with knowing that's what we had raised our children in.
Yeah, so that was on my news in Houston. And they identified the builder a couple of times. So this is the extreme ramification of not managing the air quality in a house, right? And what I see more and more, especially from the performance side, is as we tighten, we're not paying attention to these other aspects. And when we tighten, they explode in terms of their importance. And this is the result, right? This is a very visual result. Mold is black, and when it's on the ceiling, you see it and you know it. But longer term, just as we're talking about, you guys were talking about PEX yesterday with chlorine, if we don't have the code, we don't have the analysis, what we have is the science. And we know that eventually we're gonna see problems in these houses if they're too tight. And it's gonna lead us to more and more problems like this in longer terms if we don't tackle it up front. So what's causing these problems, right? Mold's the obvious one. Mold happens for really 2 reasons. Primarily because you have high levels of humidity. You have high concentrations of humidity, and you don't manage it in any way. You allow the air conditioning system to try and manage it, but as we build really, really tight, humidity spirals out of control, and a air conditioning system that's not dedicated to managing humidity is not going to be able to handle that load. The other reason that we get really high humidity is because our ventilation is not controlled. So as soon as a person walks into a house, this is my favorite quote, as soon as you walk into your house, your air quality inside is worse than it is outside because you're there. You produce humidity, you produce CO2, you dust off from the day, right? Whatever you bring into the house, you have made the air quality worse, right? You got dogs, you had cats, you had people, you had kids, and all the messes they make. Your air quality inside is worse than it is outside, assuming both things are isolated from each other. And you produce humidity, right? We sweat, we perspirate, that is a creator of humidity into a space. So if you don't ventilate to balance that out and take that air out and bring fresh air in, you're not gonna allow that house to breathe, especially with as tight as we're building them. Particulates from an allergies and sneezing and dust accumulation, that one's obvious. We probably all understand that. That's better levels of filtration. But it's also, to a certain point, again, going back to ventilation and allowing that house to breathe and taking some of that air just completely out. Just remove some of that air from the space and bring in fresh air that doesn't have all those particulates that we bring into that space. And again, allow that home to better balance with the outside and create that equilibrium. And then the last piece is CO2 and VOCs. And VOCs is really tough for us, right? Because we're talking about new houses. And new houses naturally off-gas because they have brand new material in them. And one of the biggest challenges I see, and we're going to talk about this a little bit tomorrow I think it's the last session, is managing that expectation with homeowners when they move into a new house and your building materials are off-gassing, or they bring in new furniture. That's the best time for VOCs to spike because a brand new couch is loaded with VOCs because they just made it, right? And it's gotta have a chance to stabilize in that environment. Again, that's the management aspect, and then we have to drive the education piece with the homeowners to understand what it is that we're talking about there. So there's really 4 big spots from a solutions perspective that we can tackle into this, where we have equipment now that we can use to help balance these things out, right? So we've seen the effect, we know the cause, so what's the solution, right? How do we start to look at solutions and products that can help us drive better indoor air quality in a space? And it comes kind of top down, right? Ventilation is my personal most important piece, because if you put in ventilation into a home, you at least tackle into a lot of these things. Ventilation is really the only way you can solve CO2. It's really the only way you can solve VOCs. It will help you with humidity, and it will help you with particulates. But it's not the ultimate solution for humidity and particulates. And that's one big piece of indoor air quality, is very often it's not one size fits all, and it's not one piece of equipment to just solve the problem, right? We talk about energy efficiency and we say we're gonna throw in a high efficiency heat pump and we're gonna solve the energy efficiency problem. You can't do that with indoor air quality. You have to look at your build, you have to work with your modelers to figure out what the right combination of things is based on the building science of your home. Outside of ventilation, I'm gonna skip the middle one because they stuck it in a weird spot. We've got filtration. Filtration, again, is obvious, right? You move up to higher MER filters, you filter more air. It's pretty straightforward. I have been really surprised that out of COVID, we don't see massive adoption of air filtration. There was a lot of time spent on hand sanitizer and like masks and stuff. The studies that came out about 9 months out of COVID were that if you filter your air and you get your air changes up, your ability to spread COVID drops through the floor. That's why airplanes went back so fast, because the filtration systems on those planes are astounding, right? Planes are super safe places for COVID. Airport sucks. Airport's where you're gonna get COVID. If you went on a trip and you got a COVID afterwards, don't blame the airplane, blame the airport, right? That was where you got COVID. That airplane, you were fine. Even the person sitting next to you, the filtration and the air movement and the changes is so good that they get all that COVID out and they were filtering that air. And then lastly, humidity management. Humidity management, probably the one that's closest to home for everybody. Put in a humidifier, put in a dehumidifier, put in a variable speed air conditioner that can manage humidity as a default, and you can control that. People really understand that one. That's why I have it at the bottom. It's the least exciting of this conversation because we kind of all know from a humidity management what to do. But again, it's a matter of adding all these things together and looking at your home and looking at the environment that you build your home in to understand what you need to put together. So we'll start with ventilation, and we've kind of talked about a lot of this. I go to the commercial piece on the right there. This is a really interesting study that I read. Again, I go to corporate America, right, where we metric things, and that's how everything is managed. And in order to justify ventilation to the stock market, what a bunch of construction companies did is they went out and they did a study, and they said, all right, we're going to take a building and we're not going to ventilate one and we're going to ventilate the other. So hopefully you were in the ventilated one. And we're gonna measure output from the 2 buildings and cognitive engagement and how those workers engage with their jobs and spend their days. And they saw a 61 to 101% boost in cognitive impact in the building with ventilation versus the building without ventilation. People were sleepier, people weren't as motivated, people were uncomfortable in the other building, whereas in the ventilated building, they could breathe and there wasn't as much CO2 and their brains were able to operate better because they had more oxygen in their systems and the humidity was more under control and the temperature was more under control, so they didn't have to think about it and put jackets on and take jackets off and move around and do stuff, right? Take that to a house, right? We're not necessarily talking about output, but we're talking about quality of life in your home, right? And so I'm waiting for someone to go down that study. It's not gonna be us, but to go down that study and look at, hey, how do you, it's a little bit of a creepy experiment too, but like take 2 houses and have one family that's the same family and don't ventilate one and ventilate the other and see how their lives are better. That's why we haven't done that study yet, because that's a little crazy, but if only Freud was still around. And we'd see that, right? It seems like it's a pretty good parallel. The other piece here is ventilation is really nice from an an energy savings perspective. So especially when you use ERVs. So dumping fresh air in is tough, right? Brings a lot of extra load into your house that you weren't anticipating. You're building these tight houses to drop your loads, right? You want to be able to put a smaller air conditioner in. You want to be able to, advertise this really energy efficient house. When you dump fresh air into it, you're going to struggle with that. So if you start to put in ventilators, then those ventilators have recovery capabilities and coefficients to them that are going to make your home naturally more energy efficient. So don't think about this as, hey, I'm just going to dump fresh air into my house and it's going to drive my load up by a ton to a ton and a half for my air conditioner, and all of a sudden my house is a much more expensive house to operate. That's what ventilators are meant to do. They're meant to help you and your homeowners with that energy load. And then from a code perspective, I kind of alluded to code. We're starting to see code. Oh, that got brighter. We're starting to see code start to adopt. So up in the north, there's a little bit more of it as they have to build tighter just naturally to deal with electrification. In the south, it's still the Wild West, especially where I live. So, but as those codes begin to start to march along, California is going to do what California does, as it always does. So they'll be the first. It's going to help you hit those code requirements. Filtration. So filtration, again, is kind of the obvious one. My favorite stat is that a typical home generates about 40 pounds of dust a year. That's coming out in your air filters, that's coming out in the ground, that's coming out on your cabinets and all that stuff, right? And in some way, settled dust is good because you can grab it and you can get rid of it. But ideally, removing a lot of that dust is the best way to handle it. So putting in really good filtration. This is also, fortunately, COVID did have some impact on people's understanding of filtration and how important it is. So we do see a really high demand for filtration in homes. Dyson helped us along really well too with the air purifiers and all those things that they put into spaces and made really sexy because they're Dyson. And so we do have a really good adoption from homeowners in terms of understanding air purification. The other piece, self-serving for Carrier, if you don't run dust through our coils and our furnaces, we greatly appreciate it. It makes our systems work significantly better if they're not gunked up with dust and other things that are coming through the airflow. So one piece I did want to identify, my only plug today, I promise, our Infinity air purifier. And I mostly have this up here from the claim perspective. So as we get further into air purification and making claims around air purification, this is something Carrier did when we were going through coronavirus, which was to do a test, and we qualified, and I don't know how they did it, if they had someone with COVID go and sneeze into the filter or what they did, but we kill 99% of the coronavirus particulates that pass through our filter. So this is specifically to our Infinity filter. This is a combination electrostatic and media filter, so it does both. You do still have a media filter that you change on this, so you can pull it out and remove that used filter, but it will go in and eliminate those viruses. And so as we continue on, COVID seems to be behind us. Hopefully we got another 100 years before we got another one of those, and we'll all be, either dead or artificially preserved in some way. But this is a really good product. I had in here a slide that showed the different MERV ratings. It exploded the slide deck, so we didn't show that. But there are some really great resources out there. And Tim, you actually had it on your slide there where it showed the different MERV ratings. So MERV 14 for me is minimum. That's all I will put in my house. And so driving some higher air purification in your homes is always a good idea. And then the last piece is humidity management. So again, the obvious one, probably the most straightforward one outside of removing dust. If your humidity is too high, dehumidify. If your humidity is too low, humidify. My home's in Minnesota. I had both. Ironically, I both humidified in the winter and dehumidified in the summer because it's one of those weird climates. But this piece, and one piece that doesn't get talked a lot about with humidity management, is the ability for your homeowners to save energy on their HVAC system. So we don't spend nearly enough time talking about wet bulb versus dry bulb, and I'm not going to do that today. But what I can tell you is if you are controlling the humidity in a house, your ability to use a more energy efficient set temperature is extraordinarily higher. So for example, in a home where you are not controlling humidification in the summer in Houston, you might need a set temperature of 72 degrees in order to feel comfortable in that house because the humidity is so high. If you put a humidifier or a dehumidifier in and you can drop that humidity into control, you can raise that set temperature up to 76 or 78 and still feel the same level of comfort. And that obviously from an equipment perspective and a home operation perspective drives a lot of energy savings because every time you change that set temperature up, you decrease your energy bill because your runtime goes down. And so driving humidity solutions in is a great way to help tackle into energy management in these houses. And again, if we're building them super tight, the goal is an energy efficient house. So putting in a system that allows that HVAC system to run less as the number one contributor to the electric bill is a great solution in my mind. So the last piece, and I'm going to spend a minute on this, and then we're going to talk more about it tomorrow, is the aspect of sensing and control. So one of the biggest challenges that we have as an industry is talking about indoor air quality in a way that doesn't relate it to health. I can tell you confidently there are very, very few contractors in the industry that are willing to talk about health. I have to imagine, maybe you guys are different, you can tell me I'm wrong, but in a model home, the last thing you want to do is have somebody come in and be like, do you get nosebleeds a lot, or do you have allergies, or how do you sleep at night? Like, that's not what you're selling. People walk into model homes, they walk into sales centers, and they want to talk about their countertops, they want to talk about their cabinets, they want to talk about their wall colors, they want to talk about their flooring, they want to talk about their appliances, right? They just assume that it's covered. So what I like to propose and talk about, and Tim, you brought this up from a control perspective, because for a long time we've controlled temperature. We understand thermostats, everybody knows the temperature they like. What we need to start to do is drive the control of these other aspects. We need people to understand what is the CO2 number or range where it's in control versus being out of control. And then what you can say is, well, if it's out of control, you'll get things like this and this and this. But we keep it in control. So our home controls CO2, our home controls humidity, our home controls VOCs in a way that other homes don't control them. And you can bring it to a conversation that we're able to have, as opposed to one that says, well, if you don't do this, then those other homes are going to get mold, because you can't say that either. It's not you could, I guess, but I wouldn't. Because you're just going to drive weird conversations with your buyers. So you bring it to that, and then they can go to those other homes and say, hey, do you control humidity? I'm like, well, we don't have humidifiers, dehumidifiers. Okay, so you don't control humidity, right? And it brings it to a very kind of neutral, real place where we can have those conversations. Long term, I suspect we're going to start to see more and more air quality sensing in homes. Carbon monoxide is already where it is. Carbon monoxide is where it is from a safety perspective. But I think the monitoring of CO2, I think the monitoring of particulates, the monitoring of, VOCs. What's the one I'm missing? Thank you, VOCs, is going to continue to increase in terms of people's awareness as they look at houses. And they're going to, if we don't do it for them, they're going to start bringing these things into their homes, and they're going to start making phone calls after the fact, right? So that's where we have to make a decision is, do we want to deal with it after the fact and end up on the news? Or do we want to deal with it up front, address it head on, and figure out a way to have a conversation with someone and ultimately end up putting in the systems we need to put in to be able to say that we're controlling these things? So that when these sensors start to come into the house, I can tell you when I wasn't sleeping well, the first thing I did was I went out and I bought an air quality sensor. Because I was like, what's not making me sleep well? I'm warm. I have 4 dogs in my bed, right? Like, why am I not sleeping well? I should be sleeping well. I brought it in. I set it on my nightstand. The next morning, I got the alert. I looked at the trend, and the CO2 was sky high. Done. If that's a new house and I bought it 3 months ago, my first call is to my builder because I'm under warranty. Like, why is the CO2 in my room so high? And why isn't it managed? And what's happening, right? And whether or not you did the right thing or not, you still have to answer that call, and you have to have that conversation, right? Whereas if we have a ventilator in there and we're managing that CO2, then you can go in, you can say, well, actually, why don't you just tweak your ERV a little bit, run it a little bit harder, run it a little bit higher at night, and we'll pull that CO2 out. So it's creating the ability to have the option to engage in that conversation as these things start to enter the market. And I think we're going to talk about indoor air quality sensing in a second here and how we manage that. So again, it's about building that concept of control so that when these numbers start to enter homeowners' heads, they have a frame of reference of where they're supposed to be, and then that's going to lead them to caring about it. So that's where I get to carrot versus stick. Eventually, the air quality sensor is going to be there, and we're not going to have a choice. And we're gonna have to do it because they're gonna come in, they're gonna buy a house and they're gonna get pissed off because the humidity's not managed or the CO2's not managed or the particulates are through the roof, right? And they're gonna have a sensor and it's gonna tell them, hey, something's messed up in here, something's not right. That's a phone call to you guys, right? You have to deal with that. So my last piece here, hopefully I haven't taken up too much time, and I've taken up enough time. I don't know, Tim. I feel like I've been talking a lot. Eventually, this has to all converge, right? So right now, and I will be the first one to admit that the HVAC industry as a whole leaves off the V part at the end. It's always funny when I talk to our teams and our salespeople, and I sell heating and air conditioning. And there's a V on the end, right? And that V stands for ventilation. We in the residential space, we oftentimes leave that off. And from a manufacturing perspective, that except for the rare occasion, is also left off. So most of the systems that we sell at Carrier are, ACs and furnaces or heat pumps and fan coils. And very often they do not go alongside ventilation. They don't go alongside purification. They don't go alongside humidity control. And a big part of that is because there's not the control aspect between those things. Yeah, you can buy an indoor air quality thermostat that'll trigger on and off some of those things. They run on runtime, but they're not intelligently operating, right? And so I think where we as an industry will end up is in controls and systems that can wrap that entire house together and say, all right, we've got a couple of CO2 sensors, we've got a couple of particulate sensors, we're monitoring temperature in multiple spaces and humidity in multiple spaces, and this is how we need to flex this house. We need to run the ventilator higher. Oh, we just had 11 people walk in, right? If you're watching an IAQ monitor, I can tell you when 11 people walk into your house because your CO2 is gonna go through the roof because they're breathing, right? And so, at what point do we get to a spot where you see it in the CO2 monitor and all of a sudden you turn around, your ventilator cranks up, your AC starts to run because it sees more people in the space, you adjust your set temperatures and you run. We're not there yet. I think we're getting there. And there's a lot of technology that's pushing us there. So it's just a matter of time before we can have a really intelligent system that, somebody like Carrier lets me sell, which I'm really excited about. So
very good.
So that's me.
Awesome. Well, I think you painted a really clear picture. I say I can build one house where I sleep like shit. I'm stupid. My lungs are the only air filter in the house, and I compromise my health. Or you build homes that make people smarter than their neighbor, right? And they sleep great, right? And their health isn't compromised. And you say, well, we can't really talk about that. I think we've got to talk about that. I think we've got to build a better product. If you want to get paid for building a better home, you can't not talk about why it's better. And we're going to have to get to that. So you're going to learn something now from my little superhero here. Yeah. And I promise, we're not going to give him shit about the Lobos, okay? Okay, we're not going to do that today, okay? The Lobos, come on.
Hey, it's all we got. It's all we got in New Mexico.
It is all you have. Yeah.
Tim, thank you, by the way, for the glowing introduction. I really appreciate that, and also for the bold call out for having built shitty houses in the past. And I will confess, I have built many shitty houses. My name is Brian McCarthy. I've been in new home construction since 2001. Our company is called Abrazo Homes. That company started in 2010, by the way. Our houses are a little better than the shitty ones I built in the past, but in 2001, just as an example, I should say in 2005, we built 858 homes in New Mexico in 1 year, and this was pre-2009 energy code, if you guys remember that. And I remember building houses that were 3,400 square feet, 2-story homes with 10 tons of air conditioning. We had 2 5-ton units, right? And that was because we had to make up for basically the draftiness and the air leakage that was going through these houses. So has anyone built houses in the 10-ton range of air before? No? We are way more efficient today, and our company is Abrazo Homes. And I actually started a company called Riot Technology too. I'll tell you about that in just another moment. Advance. Okay. I wanted to start with some definitions. We've covered some of these today, but VOCs, volatile organic compounds, PM10, which is particulate matter, which is 10 microns or larger. PM 2.5, which is particulate matter, which is 2.5 microns or smaller. CO2, carbon dioxide. MI, I'm not even going to try to I butcher that every time I say it, but MI is one of the off gases that you will see that is being measured in VOCs. It is in almost every paint. It is in almost every carpet. It is embedded in your sofas and in your furniture and mattresses, all sorts of stuff. So MI is in a lot of goods that we find in our homes. RH, relative humidity. ACH, air changes per hour. And of course, IAQ, indoor air quality. Can I just get a show of hands? How many of you are measuring your ACH on your homes today? And how many of you are not? How many of you don't know? And that's okay. So one thing just to talk through here is that we're facing the pressures today to tighten up our air envelopes and to build almost airtight homes, right? IECC 2024, 2024, net zero is approved. It is an approved standard of the IECC 2024 code, right? So your code adoption cycles, depending on where you are and where you're building, it will vary by what time your municipality starts to adopt the 2024 code. But I can tell you, if you're in California, net zero is around the corner. If you're in Texas, you might have 6, 7, 8 years, right, before the code is adopted. But when we get to a net zero home, the best way to achieve these net zeros is to have a very tight envelope, right? And you're probably going to have under 1 ACH, or air changes per hour, in the home, in terms of trying to create a very tight energy envelope to where, and at 0.1, at 1 or below, that is a critical threshold that we are going to have to talk about, as basically sub 1 for ACH. As the envelope improves, the natural fresh air exchange diminishes throughout the entire house. That's part of the plan, right, of energy efficiency, is you want to cool that air and keep it enclosed. But at the same time, homeowners want simplified home management and energy efficiency and a healthy home. And they're looking to you and to us, right, as the industry experts, to deliver that. It's like, I want an efficient home. At the same time, I want a healthy home. Does indoor air quality matter, and how much exposure matters? So how many of you have ever been on an airplane where you see the entire airplane's almost asleep? Anyone? When you get into an airplane, right, they have to pressurize the cabin. So you fly at 36,000 feet or whatever it might be. When they pressurize that cabin, that is changing the air pressure in the cabin, and it is dropping the air pressure from about 17 PSI down to 11 or 12. And functionally, your body is living at around 8,000 feet elevation when you're on an airplane, right? And when that happens, the air pressure drops, the oxygen levels drop, and the whole cabin falls asleep, right? In a matter of 20 minutes, you see these pictures all over the place, time and time again. In 20 minutes, your body is responding to the pressure levels. Then you feel that when your oxygen levels are depleted, right? So it is almost instantaneous in terms of the volume of air that we breathe and the effects that can have. So Cam talked about this a little bit, but what's going into our lungs? So VOCs, volatile organic compounds, are coming off of paint, carpet, furniture, mold spores, particulate matter. So PM10, this is a larger particulate matter, right? A larger molecule. Dust, smoke, pollen, and pet dander are some of the big ones that we're seeing for PM10. And particulate matter 2.5. So almost all of these are microscopic. I'll show you the scale here in just a moment. But these are chemical reactions. This is gases, cleaning supplies, and emissions, right? So these are all going to be absolutely invisible. And more, of course. So we talked about carbon dioxide and humidity. Cam covered that one. This is a really interesting fact that struck me when I read it, but it says we are exposed to more chemicals today in 30 days of our lives than our grandparents were exposed to in a lifetime. And if you think about that, ironically, we've talked about the pandemic and everything else, and everybody's going through and trying to be super diligent. And what are we using nonstop to try to manage viruses, right? Chemical sprays, Lysol, antiseptic, hand sanitizer, and we are just spreading all this chemical madness all over the place to try to control the virus. But ironically, some of those things could have been doing as much harm as good on the air quality side as well. The effects of indoor air quality. So we spend about 80 to 90% of our lives indoors. Most of it probably in your house or in your office, right? Those are the two places we spend most of our time. There are short-term effects. CO2, by the way, is, and we had a training session at one of our homes, and we had an air quality monitor in there. We brought in a dozen people or so into a 2-car garage. We were at our normal levels of CO2, which is around 450 parts per million in Albuquerque. And after 20 minutes in that room, we were over 2,200. So it was 5x of the carbon dioxide emissions in a span of about 20 minutes. And you can see this. You can start to see people yawning, falling off. And how many of you have ever been at that, that holiday party or the birthday party where you're in someone's house, there's a crowded room, and you just find yourself saying like, man, I just need to step outside and get some fresh air, right? Like, I feel like most of us have been there at one point.
The ugly part of that is CO2 is just air that other people have already breathed.
Right, exactly. Exactly. So yeah, the short-term effects that you'll start feeling from indoor air quality are feeling tired, headaches, bronchitis, severe allergies, irritation of the eyes and throat, and long-term effects. So long-term effects of living with it in poor conditions, right? Asthma, emphysema, cardiovascular disease, COPD, and even cancer. I really believe that we had Aaron Brockovich to kind of kick off the whole thing about water, and people have really become way more sensitive about water over the last 15, 20 years, rightfully so. I think the next domino to fall is air quality, right? And there's going to be more and more and more studies about the quality of the air that we're seeing, and it's going to become a hot topic. I put this slide in here to talk to you a little bit about what these are, right? And if you see the big gray cylinder here, that is one strand of human hair, okay? So one strand of human hair, and then you see what look like boulders, that's one grain of beach sand, right? If you see the PM10 are the blue particulate molecules, so those are dust, pollen, mold, etc. And you'll see there's about 5 PM10 that are the width of one human hair. And if you see PM2.5, there are 4 of those that make up the width of one PM10. Okay, so the PM10. Some of those, and by the way, I live in the desert. I'm Albuquerque, New Mexico. We have very low humidity, but we have very high levels of dust. And you've seen this before when the ray of sunshine is coming in through the right window. You can literally see sometimes the dust in the air. That's basically what I'll call your PM10 type of dust. The PM2.5s you can't see. The PM10s, your lungs actually do a reasonable job of doing some level of filtration on a PM10. A PM2.5 is so small that when you breathe it in, it actually is going all the way into your lungs through the capillary. It penetrates the capillary, it gets into your bloodstream. PM10s enter your bloodstream, and they are the deadly ones. The PM2.5s are the bad ones. And those are the ones I think that we're going to be talking about more in the future. And then this is the Sterling chart. This is an old study. I want to say it was in 1989 or so this chart was revealed, but it talks about, this is about managing the relative humidity, right? So these are the bands of humidity that exist from 0 to 100, and the risks and the concentrations you'll see of some of these different items at each band of humidity, right? So there is dry mold and wet mold. You'll have, and basically you have bacteria growth, viruses, fungi, respiratory infections, et cetera. And really, in a nutshell, 40 to 60% is your ideal range for humidity. It's really, if you can be around 50% and manage plus or minus, that is the happy spot for humidity to be located. We added this little icon on the side over here. I think people talk about home builders, and we get a bad rap sometimes, right? They're saying this is, blue collar, and you're just a builder or a contractor and all these other things. And to some degree, the amount of information that we have to know and digest in terms of systems, air control, home health, and not to mention OSHA and FHA and VA and all the regulations, all the requirements, everything else that going into. I mean, we are actually going to have to embrace having a portion of this. It's about home health. We're going to have to be a little bit of our medical advisors for our homeowners going forward, which is a little scary, a little crazy. These are the do's and the don'ts of managing IAQ, so indoor air quality. And Cam talked a lot about these, so I'll move quickly. But yes, filtration. We're recommending MERV 11 or better. Exhaust where you can. Bring in fresh air, so it's an ERV or an HRV, depending on your location. New Mexico, by the way, is the 5th largest state by land area. Our southern border is Mexico. We are basically we are the northern portion of the Sonoran Desert in Mexico, all the way up to Taos and Red River. Red River, we built a unit up there. It's at 9,000 feet elevation. So we have, I think, 4 climate zones in the state of New Mexico in one state. And your states are probably similar in terms of where you build, but you really have to design these systems based on locality, on climate, on all the other conditions as well. But bring in fresh air, use low VOC or natural products, manage the humidity levels, and measure and monitor your levels. Just by adding an air quality monitor, you're going to learn a lot about how your homes are behaving. The don'ts: don't use your wood burning stoves. Those are big no-nos. Don't overdo air fresheners and candles. Don't tell my wife, but the candles are a bad one. Don't use the harsh cleaning supplies. There's a lot of other natural cleaning supplies and even microfiber towels and just water. Certain stuff is so much better in terms of the cleaning supplies. Don't overwater your plants, which can be big mold producers if you start putting too much water in your plants. Don't believe in false prophets. So this is really, Cam alluded to this, but every single house is designed, right? I mean, you already have your manual J's, right? And they're calculating your airflow and the sizing of all your equipment and everything else. These are very highly sophisticated plans, designs, and metrics that are designed specifically around each room in the house, the total square footage. I have a hard time thinking that the air purifier that I buy on Amazon, that's a plug-in unit that sticks in my living room, is as sophisticated as the systems that have been designed for us by our HVAC contractors. And don't build snow globes. So the houses that we saw in Houston, right? This is where they built an airtight envelope, and they don't have any air exchange, right? So when you do that, that is truly one of the least safe homes that we could possibly be building. I will argue, in fact, I think I make a point of this. Sorry, I'll get to this one in a second. These are some of the things you'll need, and we talked about it, but ERV or HRV, filtration, better cleaning supplies. And then on the left, this is an air quality monitor that is tracking PM 2.5, PM10, VOCs. We're tracking and measuring all that. And I will give a quick plug. I've built a lot of homes, hopefully some better than others, but over the duration of time, some of the smart home technology became a big frustration for me because it was really designed for lifestyle components in terms of convenience for the homeowner, but it really added very little to the builder. So we started a separate company called Riot Technology, and Riot Technology, we have a whole suite of sensors and devices that are configured and designed to be integrated into the new construction build that are pulling and measuring all the data and all the performance data off of the homes, right? So we're tracking indoor air quality, power consumption, water consumption, filter changes. We have a little door magnet on your furnace or on your air handler that measures when the homeowner is changing their filter, because that's the number one most common point of deferred maintenance in a house. And I would argue that changing your filter is the most important thing that a homeowner can do. And we came up with a whole separate company that we're putting into our own homes, and we're working with other builders to put into theirs to do exactly what Cam was mentioning. We're monitoring and controlling to make sure if you have an ERV in the house, and this has happened, where an ERV gets powered off or disconnected or it's not working, that house goes from being one of the safest and healthiest homes in America to one of the most deadly. And the proper function of the equipment, not just the installation of it, but the proper function of the equipment is not being monitored. Nobody's tracking this. And that, to me, is more important than a smoke detector. A smoke detector is a hopefully a low probability event that you actually have smoke in your home. But if you have occupants in your home, the probability of rising CO2 levels is 100%. It's not a question of whether or not it will happen. It's happening. Brief conclusions. Homes are headed for net zero. Whether we like it or not, homes will probably be almost all net zero with a very tight envelope, and probably all electric within 10 years. And the solutions today, there are solutions that exist today that give us both a very safe and very comfortable home, which is great. And monitoring IEQ levels and proper function of all this equipment will be paramount, possibly even mandatory. I think the idea of having an IAQ alarm will be more important than having a smoke alarm in the future. I mean, your IAQ alarm, by the way, would capture smoke as well. But that's my presentation. And
awesome.
Thanks.
Great. So we are almost out of time here. So Jeffrey, if you could just sit right there and grab your thing. If you could just quickly, in kind of 3 minutes, what did you see when you were a mold inspector? And more importantly, explain to everybody why the teeny home is like the learning lab for air quality.
Yeah, so over a couple of years, I went through about 300 houses. And, we would get the call for multiple reasons, right? There'd be visible mold, someone would be sick in the house. I wasn't the testing company. I was the one that came in either before or after testing, put together a remediation plan, and figured out how to fix the problem, right? And so we did this, we used moisture meters, of course. We would see a lot of visible mold. Sometimes you wouldn't see a lot of visible mold. We'll get to this one here in a second, but the interesting thing is that about 70% of what we saw was water leak damage, right? Everything from failed plumbing. On the new construction, it was typically nails or screws through water pipes, right? About 20% of it was roofing related, right? The flashing was done wrong, or the roof was damaged, not repaired over time, deferred maintenance. And about 10% of it was really poor ventilation, most of the time in bathrooms, right? Is the ventilation wasn't even there, or the vent pipes weren't even hooked up, right? So Tim was talking about the smaller homes, and we were building 400 square foot units in Colorado. And one of the things that we knew right off, we were building with SIPs. And so these things were super, super tight, even closing the front door a little challenging. And so we had to come up with a solution. They looked somewhat like this. But we needed a simple solution for indoor air quality, and we used a unit like this, right? This is a Zender unit. I don't sell for them. I don't get a commission. It just what we used because it was a very simple unit, single penetration, where we could exhaust what was coming out of there. You know, in 400 square feet, the concentration, the really small volume of air is like Tim was talking about, 1 or 2 people sleeping, somebody taking a shower, somebody cooks fish in the kitchen. I mean, it's the whole house, right, is affected.
And that's not just a vent, that's a heat exchanger.
It is. It's an ERV, believe it or not. And we didn't have the technology back then, the sensing and the integration technology. We're getting there, as Cam was talking about. But this was manually controlled by the homeowner or the occupant in this case, because these were employer-based housing, and they could control the fresh air in the house. And so with the cold temperature and dryer in Aspen, where a lot of these units went, you know, they were using these to ventilate the house, right? And it would warm the air that was coming in with the air coming out.
All right. Well, we are plumb out of time. I hope today was useful. I think it was a good second event. So you know the routine now, but first I'd like to thank the 3 experts that came in here and shared their knowledge with us. Once again, it takes some time, effort away from their jobs and what they really do. And so, thank you very much.